to our study entitled Recovery of Hexavalent Chromium from Mine Wastewater Runoff using Cooperative Interaction of Ionic Liquid with Magnetic Nanoparticles. During the past few decades, most of the mines worldwide have been confronted with the problems involving mine wastewater runoff containing heavy metals into surface, and the worldwide mining industry is facing enormous and formidable challenges with these heavy metals. Heavy metals are found naturally in earth that has a relatively high density and are toxic at low concentrations. Toxic heavy metals such as chromium, cadmium, lead, arsenic, mercury, nickel, and copper tend to persist and bioaccumulate in the environment and cannot be easily removed without advanced treatment. Among all other heavy metals, chromium, particularly with +6 oxidation state, is one of the most widely studied metals due to its toxicity. Objectives of this study. The main objective of this study is to recover chromium-6 metal minerals using green hydrometallurgy in wastewater runoff. Especially, it aims to synthesize the ionic liquids for the leaching of the heavy metal, determine the optimum leaching efficiency of ionic liquid in the metal extraction, specifically metal chromium in wastewater runoff. Assess the effects of the different variables such as absorbent dosage and contact time to the absorption capacity of the synthesized ionic liquid. Determine the recovery effectivity of the optimized ionic liquid with magnetic nanoparticles and metal extraction, specifically the metal chromium in mine wastewater runoff. Methodology. The initial concentration of the mine waste sample is characterized using the X-ray fluorescence to see the initial composition of the mine waste sample. Then, the mine waste sample is tested with varying dosage of the ionic liquid with the time being constant to see how the absorbent dosage affect the leaching of the sample. This characterization is repeated in the other parameter by varying the constant. Then, we find the optimum contact time and the ionic liquid's concentration for the absorption. The sample is added with magnetic nanoparticles to recover the leached metal in the solution and then characterized using X-ray fluorescence to see the difference between initial and final concentration of the heavy metal in the sample. Synthesis of ionic liquid. First, about 10 grams of butyl metimidazolium chloride is added with 30 ml of bromide along with 10 ml of distilled water and was stirred at the room temperature at 400 revolutions per minute for 24 hours. Then, the mixture undergone rotary evaporation at 85 to 90 degrees Celsius to form butyl 3-metimidazolium bromide and use it as the ionic liquid. Efficiency of the ionic liquid. The ionic liquid's efficiency in removing heavy metals such as hexavalent chromium was examined. This experiment used mine wastewater runoff sample generated in varied quantities. By altering one parameter while keeping the others constant, the effects of the parameter such as ionic liquid concentration and contact time were investigated. The concentration of chromium solution was determined using X-ray fluorescence. Effect of absorbent dose. The sample were being withdrawn within 30-60. Effect of absorbent dose. When the mine waste sample was leached using 5% of the 10% ionic liquid solution, the absorption of the hexavalent chromium was found to be 85%. The mine waste sample leached with 1% and 3% of a 10% ionic liquid solution yielded 81% and 83%. Respectively, which is relatively low in comparison to the mine waste sample leached with 5% of the 10% ionic liquid solution. It is evident that there is significant difference between 85%, 83%, and 81% removal efficiency, which means that the maximum removal efficiency of the ionic liquid to absorb hexavalent chromium was attained at 5% of the 10% amount of absorbent material. Thus, the absorption was attained at 5% of the ionic liquid solution. Effect of contact time. The samples were being withdrawn within 30, 60, 90, and 120 minutes intervals. The results showed that 21% of the absorption was observed within the first 30 minutes, 85% for the next 60 minutes, 20% at 90 minutes, and 23% was obtained at 120 minutes. The result clearly shows that the leaching at time equal to 60 minutes yielded the highest percentage of absorption. Hence, the optimum incubation time was achieved at 60 minutes under specified conditions. Recovery of hexavalent chromium using ionic liquid with magnetic nanoparticles. The optimal condition of the removing of hexavalent chromium from the real mine wastewater sample was used 0.05 grams of 10% ionic liquid solution and 60 minutes of agitation duration. Previously, the hexavalent chromium concentration was determined to be 0.234 milligrams per liter. The absorption process was carried out in the same way as the previously described in this paper. The results showed that the final hexavalent chromium concentration of 0.32 milligrams per liter was detected after the application of the synthesized ionic liquid. Using the magnetic nanoparticle, the recovery of hexavalent chromium yielded 90% of the leached sample. The results suggest that using the optimized condition, the ionic liquid was able to remove 85% of the hexavalent chromium from the real wastewater sample using 5% of the 10% ionic liquid solution. And the total recovery of hexavalent chromium using M and P yielded 90%. Thus, this study further implies that indeed, the synthesized ionic liquid added with magnetic nanoparticles is an effective material for removal of the hexavalent. Conclusion. The leaching efficiency of the ionic liquid is dependent on the absorbent dosage and contact time. The leaching efficiency of 85% was obtained at 0.05 grams of ionic liquid solution and can be considered as the optimum dosage level. The optimum incubation time, which obtained 85% removal using ionic liquid, achieved at 60 minutes under the specified conditions. Using magnetic nanoparticle, the recovery of hexavalent chromium yielded 90% of the leached sample. This study confirms that the synthesized ionic liquid with NMP can be used as an absorbent tool for various metals, especially hexavalent chromium. Recommendation. With the success of the study, it is highly recommended to conduct the following experiments to improve the study. First, test the efficiency of absorbent concentration using higher concentration of synthesized ionic liquid in mine wastewater runoff. Apply synthesized ionic liquid in the leaching metals such as iron, nickel, zinc, manganese, calcium, among others. Test the absorption of the synthesized ionic liquid by applying different pH in the mine wastewater sample. Applying the absorption of ionic liquid and NMP in actual mining area. Synthesized ionic liquid with magnetic nanoparticles. Thank you.